For the longest time, the highest levels of math felt like this uniquely human place, right? A world where creative intuition was totally king. But what if I told you an AI just crashed that party? And not only crashed it, but walked away with a gold medal performance in one of the world's toughest math competitions. Let's break down how on earth that happened.
So that's the big question we're digging into today. It's this classic showdown, the subtle, creative, intuitive human mind versus the raw, logical power of artificial intelligence. And the battleground for this fight? It's a place you probably wouldn't expect: high school geometry. So where is this all going down? It's at a competition called the International Mathematical Olympiad, or IMO. And trust me, this is not your standard high school math test. This is the absolute ultimate gauntlet.
To solve these kinds of problems, you can't just crunch the numbers. No, you need that spark, that aha moment, that flash of insight to even find a solution. And that's exactly why Olympiad geometry has been a kind of holy grail for AI research. For ages, everybody just assumed it required a type of creative thinking that, well, only humans had.
Okay, so enter our hero, Alpha Geometry. Now, the first version of this AI, it took a really cool and unique approach to cracking these problems. Instead of just relying on one method, it used something called a neurosymbolic system, which is really just a fancy way of saying it has two brains.
So yeah, this system isn't just one single AI. It's much more like a partnership. The whole goal was to build a machine that had both this wild, creative side and a super-duper rigorous, logical side. It was all about mimicking how a human mathematician might actually work through a problem. And here's how that little partnership works. On one side, you've got the neural model. Think of it like the intuitive artist. It looks at a problem and just starts suggesting clever ideas, these what if we try this kind of moves. Then, on the other side, you have the symbolic engine, which is the meticulous, no-nonsense fact-checker. It takes every single suggestion from the artist and rigorously checks it against the cold, hard rules of logic. But here's the thing. That first version, Alpha Geometry 1, it had a ceiling. Now, don't get me wrong, it solved 54% of recent IMO geometry problems. That's incredible. But it's not a gold medal. Not even close, really. To get to the top, the team had to close a pretty significant gap.
And that, my friends, brings us to Alpha Geometry 2. The team went right back to the drawing board and gave this AI a massive, massive upgrade. You gotta picture this, like the training montage in a movie, right? Where our hero just gets stronger, faster, and way, way smarter.
And the upgrades were, well, they were across the board. First, they gave it a much bigger vocabulary, so it could understand more types of problems, jumping from covering 66% of problems to 88%. Then, they totally turbocharged its logical engine. They swapped in the much more powerful Gemini model to be its creative brain, and they gave it a completely new strategy to search for solution.
And when I say turbocharged, I am not kidding. The new symbolic engine, that fact-checker brain, was rewritten in C++, and it became over 300 times faster. Just think about that. It meant the logical brain could fact-check ideas from the creative brain at a blistering pace, letting it explore way more possibilities in the same amount of time.
This new search strategy, SKES, is also really fascinating. Instead of just one AI working alone, I want you to imagine a whole team of detectives, and they're all attacking the same case but from different angles. Now, whenever one detective finds a really important clue, they immediately share it with everyone else. This shared knowledge helps the whole team zero in on the solution much, much faster. It's brilliant.
All right, so with all these incredible upgrades, it was time for the final exam. Could this new and improved AI actually compete with the best and brightest minds on the planet? Well, honestly, the results were just staggering.
This right here is the result of that training montage. Alpha Geometry 2 solved 42 out of 50 geometry problems from recent Olympiads. That is a solve rate of 84%. I mean, what a massive jump from the 54% its predecessor managed.
So, what does an 84% solve rate actually mean in a competition this intense? Well, take a look at this. It means Alpha Geometry 2 didn't just get a good score. It surpassed the average performance of a human gold medalist. For the very first time, an AI system has reached this level of performance. This is a huge deal. And it wasn't just about getting the right answer. The way it found the answers was honestly breathtaking. For some incredibly hard problems, like one from the 2024 Olympiad, its solutions were elegant, completely unconventional, and were considered by human experts to be superhumanly creative. I mean, listen to this quote. It's directly from the research paper.
For that 2024 problem, it found a full, correct solution in under 30 seconds. And that solution was verified and given a perfect score by a 2-time IMO gold medalist. That is just an insane combination of speed and quality.
So, Alpha Geometry 2 has conquered the IMO. Game over, right? Well, not exactly. What's the next mountain to climb? Because believe me, the journey for AI and mathematical reasoning is far from over.
The team is already looking ahead to the next frontiers. There are still types of problems it can't quite handle yet, like ones with inequalities or 3D geometry. They're also working towards a fully automated system that can read a problem just like you or I would and produce a solution. And, maybe the most exciting part, they want to apply this incredible reasoning power to other fields of science.
And that's really the thought I want to leave you with. We've just seen an AI show a spark of what we always thought was a uniquely human thing, intuition. It's a landmark moment. So if a machine can reason this creatively in the abstract world of geometry, what happens when we point that same intelligence at the great scientific and societal challenges of our time? The possibilities are truly profound.